before anyone had ever seen it. Someone knew it was there. Not from a telescope, not from a photograph, from numbers. From the patient, careful observation that something was pulling at the orbit of Uranus in ways that couldn't be explained. A gravitational whisper from something hidden in the dark. In 1846, two mathematicians working independently on opposite sides of Europe calculated where that hidden object had to be. They handed their coordinates to astronomers. The telescopes turned, and there it was. Exactly where the mathematics said it would be. Neptune. The first planet humanity found, not with our eyes, but with our minds. To understand Neptune, you have to understand what it means to be that far away. It orbits the Sun at roughly 3 billion miles. Light from the Sun, the same light that warms your skin on a summer afternoon, takes 4 hours to reach it. By the time it arrives, it is 900 times dimmer than what we experience on Earth. The Sun, from Neptune's surface, would look like a very bright star. Warm enough to see, not nearly warm enough to feel. A year on Neptune lasts 165 Earth years. When astronomers first observed it in 1846, it was completing a single orbit that had begun before the American Civil War, before the invention of photography, before most of the countries on Earth's map existed in their current form. It completed that orbit, its first full year since discovery, in 2011. 1 year in the span of human civilization. And yet, Neptune, despite receiving so little from the Sun, is anything but still. It holds a record that scientists still struggle to fully explain. The fastest sustained winds in the solar system. Gusts exceeding 2,000 kilometers per hour, faster than the speed of sound. Jet streams that circle the entire planet, carrying storms the size of Earth embedded within them like dark stones in a river. Where does this energy come from? Neptune receives almost nothing from the Sun. It should, by every intuition, be quiet and frozen. But Neptune generates its own heat. Deep within its interior, the planet radiates nearly 3 times more energy than it receives from the Sun. A slow, ancient warmth, perhaps left over from its formation, perhaps from processes we don't yet fully understand, powering winds that should not exist at the edge of the solar system. Neptune is not cold because it's far from the Sun. It is cold despite burning from within. When Voyager 2 passed Neptune in 1989, the only spacecraft that has ever visited, it photographed a storm larger than Earth rotating in the southern hemisphere. Scientists called it the Great Dark Spot, a vast, deep cyclone, dark against the planet's brilliant blue. When the Hubble Space Telescope looked again a few years later, the storm was gone. Not weakened, not diminished, gone. And elsewhere on the planet, a different storm had appeared. Neptune's great storms do not age and fade like Jupiter's. They appear, they dominate, and then they vanish, absorbed back into the wind as though they were never there. Whether they dissipate or simply sink deeper out of view is still not fully understood. Neptune is a world in constant, self-powered motion, and it does not explain itself. Deeper than the winds, deeper than the storms, the pressure inside Neptune becomes something our instruments can describe, but our intuitions cannot follow. At a certain depth, the crushing weight of the atmosphere above begins to do something remarkable to carbon, the same element that forms graphite, that forms the cores of pencils, that makes up a significant portion of every living thing on Earth. Under enough pressure, carbon atoms lock together differently. They compress. They crystallize. Scientists believe that within Neptune's mantle, it rains diamonds. Not metaphorically, actual diamond crystals, formed from compressed carbon, falling through superheated fluid under pressures millions of times greater than Earth's atmosphere. Some models suggest these diamonds may eventually sink to the core and accumulate there, a vast buried treasure at the center of a world we have visited exactly once. A planet with a diamond core, wrapped in supersonic wind, glowing blue in the dark. Neptune's magnetic field is one of the strangest in the solar system. On Earth, our magnetic field is neatly aligned, roughly, with our rotational axis. It behaves as expected. On Neptune, the magnetic field is tilted nearly 50 degrees away from the planet's poles, and offset from the center of the planet entirely. It is as though the magnetic field belongs to a slightly different world than the one generating it. The result is a field that wobbles dramatically as Neptune rotates. The boundary between Neptune's magnetosphere and the solar wind shifts and fluctuates in ways that no other planet in our solar system produces. Every rotation creates a new configuration. Scientists believe this may be caused by the behavior of electrically conductive fluid in Neptune's interior, a layer sometimes called a superionic zone, where water molecules are broken apart by pressure into something that exists between solid and liquid, conducting electricity in ways that produce this tilted, restless field. Neptune's compass doesn't point north. It points somewhere new every day. Of Neptune's 16 known moons, one stands entirely apart. Triton. It is the 7th largest moon in the solar system. Its surface temperature falls to nearly -400 degrees Fahrenheit, making it one of the coldest measured surfaces anywhere we have looked. And yet, despite that cold, Triton is geologically alive. Voyager 2 photographed active geysers erupting from its surface, dark plumes of nitrogen gas shooting kilometers into the thin atmosphere before being blown downwind in long, dark streaks across the pale terrain. A moon so cold it has active geysers. There is something quietly moving about Neptune. It is the last of the 8 planets. Beyond it, the solar system continues, in ice and rock and cold, but nothing else of Neptune's scale remains. It marks the edge of the familiar. And it was found not by sight, but by the simple, stubborn belief that if something is pulling at the universe, something must be there to do the pulling. That mathematics, written on paper in Europe in the 1840s, could point a telescope at a world 3 billion miles away and be exactly right. That is what Neptune reminds us, before anything else. That the universe is knowable, that its rules are consistent, that attention and patience and careful thought can reveal things we cannot yet see. Neptune will keep burning from within. Its winds will keep screaming. Its storms will keep appearing and vanishing. Triton will keep drifting, slowly toward its end. And the sun it barely knows will keep flickering, distant and small, at the edge of its sky. The last lighthouse, still on.